Hello friends. So today I am going to solve one problem of Codeforces that is named as median maximization. It is a very popular problem. Let's see how we can solve it. So in the question you are given two positive integers n and s. Okay. Now, what we have to do is find the maximum possible median of an array of n non-negative integers, not necessarily distinct. It means that n non-negative integers among them the numbers can be same, such that the sum of its elements is equal to s. So the n elements that we should choose, and we have to guarantee that the sum of the n elements should be equal to s. Okay. Now here is a definition of median. A median of an array of integers of length m is the number starting on the ceiling of m by 2th position in the non-decreasing order of elements. It means that we have to first sort the numbers given in the array, and then we have to find the element in the ceiling of m by 2th element. Okay. I hope that you have learned about the median in higher classes. Okay, so there exist other definitions of the median, but in this problem we use the described situation, described definition. Okay, so input the first line contains a single integer t, and then it contains two integers n and s, that is range from 1 to 10 to the power 9, the length of the array and the required sum of the elements. So for each test case, print a single integer, the maximum possible median. So let's see some examples. Okay, so sorry, sorry. Okay, so here I am writing n and here I am writing s. Okay, so if n is 1 and sum is 5, and what will be my output? Okay, what will be my output? So the number required, sorry, the given n is 1, so there is only one element, and the sum is 5. So what can be the number? It is 5. So in this case, median is 5. Okay. Now let's take another example. Let's suppose the number of n is given as 2 and sum as 5. So what will be the output in this case? See, the maximum numbers that we can choose is 2 and 3. Okay. 2 and 3 is the number that we only choose such that sum of the elements is 5. So in this case, my median will be what? Median will be, so here number of elements is 2. We have to divide it by 2 and we have to take the ceilings. That is 1. So the it is coming the position. Okay. And we have to take one based indexing. So my median will be 2. So let's confirm it. See, 2 5 is 2. Now let's take another example. N is 7 and S is 17. Okay. So what will be the output in this case? So let's see. So there are 7 elements. So let's build the array. Okay, so this one, 2, 3, 4, 5, 6, and 7. And 17 is the required sum. Okay. Now our target is to maximize the median. Okay, maximum the median. How we can do it? So we can do it by ensuring that first we have to find the median elements position. Okay, so 7 by 2, and we have to take the ceiling. So 7 by 2 is 3.5, and 3.5 ceiling is 4. So my median will lie in this position. Let's suppose, what will be our approach? Our approach will be make the elements. Okay, make the elements. Uh, okay, the positions that are in previous of the position of the median element. So what I am trying to say is the median position is 4. So the position remaining in the left of that median's position, we will make it 0. Why I'm making it 0? This will ensure that the median is maximum. So let's see what happens if the median is 1? Okay, so the remaining elements can be greater than equal to 1, greater than equal to 1, and greater than equal to 1. Okay, because the whole array must be in sorted order to find the median. Okay, so let's suppose we are taking it as self as 1. Okay, so what is the sum? 4. 4 is less than equal to 17. Yes, so our maximum median can be 1. Okay, can be 1. Now let's increase the median. Okay, now let's increase the median. So I am supposing that if the median is 2, what will be my sum? The sum will be 8. Is 8 less than equal to 17? Yes. So 2 can be my answer. 2 can be my answer. Now I am making it 3. Okay, I am making it 3. 3 into 4 is 12. Is 12 less than equal to 17? Yes. So 3 can be our median. Okay, 3 can be our median. And how we'll make it 17? By adding 1 to each element. So if we add 1 to each element, so it will become 4, 4, 4, and 4 3s are 12, 12 plus 3, 15, 15 plus 1 is 17. So in this way we can ensure the median is 3. Okay, now let's suppose we take all the elements as 4. We take all the elements as 4. So 4 into 4 is 16. 16 is less than equal to 17. Yes, and for making it 17 we add 1 to the last element. So as you can see, the median is 4, and it is the, and I will update the maximum median as 4. Now let's suppose we take 5 as all the elements. Okay, I am taking 5 as the median. So this will be 5, this will be 5, this will be 5, this will be 5. Now 5 into 4 is 20, and 20 is greater than 17. So this will not be the median. So 4 is our answer. Okay, so in this case output will be 4. Now let's discuss how we can solve this problem. Okay, just give me 1 second. Okay, so I'm good. How we can solve the problem? So let's suppose there are given n elements. Okay, n elements. Let's suppose my median is x. Okay, my median is x. So x is the median. X is the median, and it is highest. Okay, it is the highest. What will be its position? Its position will be ceiling of n by 2, and that can be written as floor of n by 2 plus 1. Okay, so the median position is n by 2, n by 2 plus 1. Okay, floor of n by 2 plus 1. So this all the elements will be x. Okay, and what will be the number of these elements? So how many elements will be x? The number of elements with x is n by 2 ceiling. Okay, so what I am trying to say is, what I am trying to say is, this is the array. Okay, this is the array, and and the see. Let's take the example. Let's take this example: 7 and 17. 7 and 17. So 1, 2, 3, 4, 5, 6. Okay, 7 and 17. So my median's position will be ceiling of 7 by 2. So 7 by 2 is will giving us 4. Okay. So let's suppose the maximum median is x. So from 4 to 7 it will be filled with x. Okay. Now taking x as the median and into the numbers of elements that are x, which is 4. This value should be less than equal to 17. Okay, and what x should be less than equal to 4, and what was my answer in this case? 4. So in this way I am getting the answer. So what we have to do is first take the input n and s, find out the position. So position will be n by 2 plus 1, and output will be s divided by position. So this was the whole problem. Okay, so now let's check the code. So for you guys I am again doing. So NL represents a long I comma j comma k comma n comma s. So I take the input sin, n and s. Okay, and I will find the position of the median. Position of the median will be n by 2. Okay, n by 2 plus 1, n by 2 plus 1, and I will simply see out s divided by position. That will give the maximum median. Okay, so now let's submit the problem. So P1 and then submit. So it is accepted.